Okay, so now we're going to talk about group theory problem 4 from January 2022. So this problem says let G be a finite group and let P be a subgroup of G such that it's a Sylow P subgroup, and let the normalizer of P and G be denoted by n sub G P. Also let H be a subgroup of G and let the normalizer of P and G be contained in H. So now we want to prove that the normalizer of H and G is equal to H. So the proof goes like this. So we want to show double containment. So that H is contained in the normalizer of H and G is clear, because if I take an H and H and I conjugate H by it, that stays in H as a result of H being a subgroup and hence closed under its operation. So this means that for every H and H, it's in the normalizer of H and G. So next we want to show that the normalizer of H and G is contained in H. So this is a little trickier of an argument, but first we're going to notice that P is a Sylow P subgroup of G, and P is contained in the normalizer of P and G, which is contained in H. So this means that P is a Sylow P subgroup of H. So now, because H is normal inside of its normalizer by the definition of normalizer, we will apply a Frattini argument to the fact that P is contained in a Sylow P subgroup of G, and H is contained in the normalizer of H, and H is normal in the normalizer of H and G. So the Frattini argument says then that H times the normalizer of P and G is equal to the normalizer of H and G. So since the normalizer of P and G is contained in H, we can write any element of the normalizer of P and G as H prime or H bar. So if we take X to be in the normalizer of H and G to be arbitrary, then what we've said is that we can actually write it as H times H bar. So since H times H bar is contained in H, because both of those elements are in H, and H is a subgroup of G, we can conclude that H times H bar is contained in H. So this means that X was in H, and therefore, because X was arbitrary, that means that for every X in the normalizer of H and G, that X is also in H. And so therefore, since we have double containment, that means that H is equal to the normalizer of H in G.